Hello and welcome to lesson 7, where we return to look at the periodic table, but relating some of the information from it to the formation of ions and then looking at how to write formulae for ionic compounds and also for covalent molecules. Let's have a look. Returning to the periodic table, and you've got group 1 and you've got group 2. Group 1, you should recall, contains lithium and sodium and potassium, a number of elements that have one valence electron. When that valence electron is lost, then sodium, for example, forms a sodium ion with the electronic configuration 2,8. That gives you a positive ion, Na positive. Then looking over down here to the halogens, the first member of the halogens, fluorine. And looking here at fluorine, it gains an electron to form an F negative ion. Now when you have to write the formula of an ionic compound like sodium fluoride, what you need to have in mind is simply that the valency or the charge on sodium is 1 positive and the valency or the charge on fluorine is 1 negative. With these two valencies, what it tells you is that Na would combine with F, and each of these would neutralize or cancel each other, and then you get the formula NaF. For members of group 2, like calcium, you have a charge of 2 positive. And if you have something from this section here, group 16, or group 6b, as some people call it, group 16 is what we would call it in IB chemistry. And in group 16, you've got oxygen. Oxygen loses 2 electrons to form a stable electron configuration. And when it does that, it forms an O2 minus ion. Calcium and oxygen, again, 2 positive and 2 negative would cancel each other, and you get CaO. But what about if you have something like sodium oxide? Then the 1 that's understood comes next to the oxygen, it's not included, and the 2 over here goes next to the sodium. So you write Na2O. What about if you had calcium fluoride? The 2 from the calcium comes next to the fluorine, and the -1 comes over here, but no 1 is required in the formula. Wherever we are going to have the need for a 1, whether it's in a formula or even in a balanced equation, as we will see soon, there's no need to include the 1. The 1 is understood. Another example, aluminum oxide, Al3 positive and O2 minus, the 3 comes over here and the 2 goes over there. So there's just a movement of these numbers really, wherever you're dealing with ionic compounds. It's just about moving this 1 down here and that 1 over there. This 3 down here and that 2 over here, and you get Al2O3. Now we'll consider polyatomic ions, because ionic compounds are not just formed between one ion like sodium and another ion like chlorine and you get sodium chloride. Sometimes we have these polyatomic ions, and these are just some of them listed here. If you have a polyatomic ion and you want to write the formula of something like sodium carbonate, then what you'll do is you have to bear in mind that this 2 must go down here next to the sodium. And the 1 that's understood, removing this 2 from here, goes around the CO3. And because it's a 1 and the 1 is understood, then there's no need to actually include it. And the formula for sodium carbonate, Na2CO3. Now let's take another example. Aluminum carbonate, Al3 positive, and carbonate, CO3 2 negative. Now this 3 must come outside of the carbonate, and this 2 must go with the aluminum. So therefore we'll have to write Al2 CO3, putting the entire polyatomic ion in brackets and putting a 3 outside of it. Knowing the charge or the valency on a particular species is very useful for determining its formula. Although it doesn't always work and there are many exceptions, let's take another example like carbon dioxide, CO2. Now this does not have a positive ion and a negative ion. This is a covalent molecule. But carbon has a valency of 4 and oxygen has a valency of 2. So therefore, it takes 2 oxygen atoms to share and to covalently bond to carbon to form CO2. And then you could have examples like O2 with 1 oxygen sharing 2 electrons with another oxygen, N2 with 1 nitrogen sharing 3 electrons with another nitrogen, Cl2, F2, all of these gases. But of course, there are many formulae that you do have to know. For instance, carbon monoxide is CO. That is a little bit more technical and difficult. And then there are a range of oxides of nitrogen, for example, like N2O and NO2 and NO. And all of these will be covered later on. But for now, writing the formula for simple structures like CO2, sodium chloride, sodium hydroxide, sodium carbonate, we can use this method, and we'll use it as we move in to look at how to write equations and how to balance them, and then how to apply all of what we've learned in carrying out stoichiometric analysis.